Good day everyone, Dr. Polaris here. The end of the Eocene was a difficult time for Alter-Earth's faunal communities, but especially so for those dependent on the sea. The splitting of Antarctica from South America and Australia led to the formation of a circumpolar current for the first time, triggering the development of an ice sheet that began to creep across the continent. This also led to a significant downturn in global temperatures, altering the makeup of faunal communities worldwide. On land, the shift towards an icehouse climate led to a drastic reduction of closed tropical forest ecosystems across the northern hemisphere. Rainforests disappeared over vast areas of the Earth to be replaced with dry open woodlands and savannas. Animals adapted for tropical conditions either became extinct or saw their ranges restricted to lands closer to the equator. In the oceans, the impact of this cooling event was even more dramatic. This was a turbulent period for Alter-Earth's marine animals. Many of the dominant Eocene groups experienced rather severe reductions in diversity or full-on extinctions. The mosasaurs, the premier lineage of marine reptiles since the late Cretaceous, were highly diverse by the end of the Eocene. The largest of all marine animals at the time were members of this group, particularly the clade Hydrachini, which were the apex predators of Alter-Earth's Paleogene oceans. The type genus Hydrachos was a native of the late Eocene and inhabited a vast swathe of ocean stretching from the eastern United States to the coasts of ancient India. 4 species are known, with the largest and last, Hydrachos magnificens, reaching lengths of up to 22 metres and weighing 35 tonnes. All other members of Hydrachini were smaller, but were still significantly large predators no less than 8 metres long. Their skulls and teeth were powerful and robust, suggesting a macro-predatorial lifestyle, hunting sizable fish, sharks, plesiosaurs and other mosasaurs. Their range was global, with fossils recovered from marine sedimentary deposits on all continents including Antarctica. The clade was closely related to the late Cretaceous genus Mosasaurus and probably evolved from it during the Paleocene. Many groups of these aquatic lizards were present in the Eocene seas. Members of Pronathodontini were also commonplace, being generally smaller than their Hydrachean relatives. Ranging between 4 and 12 metres long, these animals were generalist opportunistic predators with very broad diets. Preserved stomach contents from one species, the 10-metre Orchosaurus atrox, demonstrate a diet of large fish, turtles, cephalopods and smaller mosasaurs. Some genera possessed stout and robust teeth near the back of the jaw, indicating a more specialised hunting strategy, probably mainly feeding on turtles and other hard-shelled surface-dwelling animals. Unlike their sister clade, Globidensini, Orchosaurus and related genera were probably animals of shallow water ecosystems, and caught prey while swimming out in the open. Members of Globidensini were altogether more specialised, possessing distinctive bulb-shaped teeth, wide snouts and large orbits. These were clear adaptations for crushing hard-shelled prey, especially ammonites, nautiloids and bivalves. The massive tylosaurians were very successful during the late Cretaceous and Paleocene, but experienced a marked decline in the Eocene. The reasons for this are still not well understood, but it has been speculated that it may have something to do with increased competition from the more derived Hydrachini and Pronathodontini. They vanished from the fossil record by the Middle Eocene. Their relatives, the Halisaurians, had a significantly easier time of it. Emerging with a strong presence into the Paleocene, most were relatively small, slender predators that fed on fast-swimming fish and cephalopods. Members of this group possessed the largest orbits of any mosasaurs by that time, highly suggestive of a deep-water hunting niche. Their teeth tended to be strongly recurved and blade-like, allowing these predators to tightly grip their small, slippery prey. These were the most common of the smaller mosasaurs, living throughout the world's oceans. They ranged in length from 3 to 6 metres and spawned many subclades during their Eocene heyday. A representative genus was Nicorsaurus blainvillei, a 3.5 metre piscivore discovered in the early Eocene London clay beds of the United Kingdom. Remains attributable to the same animal are also known from contemporary sites in Belgium and Germany. The last of the major Paleogene mosasaur lineages were the early members of Plottosauroidea. These were the rarest but most derived of all mosasaurs, demonstrating several anatomical and behavioural similarities to the long-extinct ichthyosaurs. Plottosauroid bodies were fusiform and torpedo-like in shape, enabling effective long-distance movement through the water. Their caudal tail flukes were large and deeply curved, while some genera bore a prominent dorsal fin. Unlike other mosasaurs, these animals possessed long, slender jaws with needle-like teeth, perfect for capturing their preferred prey, cephalopods and small fish. Another feature unusual among mosasaurs developed by Plottosauroids was the sometimes complete loss of teeth altogether. Members of the family Tengonathidae were entirely toothless and seem to have been suction feeders of some sort, showing a degree of convergent evolution with the ancient ichthyosaur Shastasaurus. Unlike the latter, however, Plottosauroids were not colossal animals, generally ranging between 5 and 9 metres in length. And yet, despite all this diversity, the end of the Eocene was a disaster for mosasaurs. All groups except for the Plottosauroids and the highly specialised Globidensini became extinct at the Eocene-Oligocene boundary. Even the two lineages that did make it into the Oligocene did so with a low species count, with both suffering the loss of entire subgroups during the transition. While the Globidensini never really recovered from this blow, surviving as rare durophagous mollusk hunters until modern times, the Plottosauroids quickly recovered and diversified explosively. During the Oligocene, members of this clade continued their adaptations for fast swimming and actively predaceous lifestyles. All of the modern Holocene lineages of Plottosauroids began to develop by the end of the period, but there were also many evolutionary one-offs and dead ends unique to the period. In overall form, the Plottosauroids resemble the odontocetes from our Earth or ichthyosaurs. However, unlike the former, these mosasaurs do not hunt using sonar. Instead, like the ichthyosaurs once did, they utilise strong vision, but have also developed a highly sensitive Jacobson's organ that aids in their underwater sense of smell. Also, unlike the cetaceans of our Earth, the mosasaurs never evolved into a filter feeding niche. In that sense, they can be somewhat comparable to dolphins, porpoises and beaked whales. Other marine reptiles thrived in the Paleogene as well. Distant relatives of the mosasaurs, the varonoid family Pachyvaranidae, experienced something of a boom in diversity during the Paleocene-Eocene thermal maximum. Descended from the Maastrichtian genus Pachyvaranus of Morocco and Syria, these carnivorous semi-aquatic lizards could be found across the ancient Tethys Sea during the Paleogene. Genera were all predatory and were rather large in certain cases, ranging from 1 to 3.2 metres long. As with their living Holocene relatives, Paleogene Pachyvaranids were quite conservative in appearance, strongly resembling the river monitors of the genus Varanus from our Earth. In life, they lived like carnivorous versions of marine iguanas, gathering along beaches, shorelines and mangrove swamps, diving beneath the waves to hunt for fish, crustaceans and hatchling marine reptiles. By the later Eocene, they had spread to India and Pakistan, a region in which these piscivorous lizards still thrive today. Holocene representatives can be found in a wide arc stretching from Central Africa through India, Southeast Asia and Australia. Indeed, some of the Indian and Australian forms are quite derived, being more heavily adapted to an aquatic or riverine existence. Another lineage of squamates, the snakes, were widespread in the seas and rivers of the Paleogene world. A few genera of the Matsoidae family of basal snakes took to an aquatic existence, particularly in and around the Tethys Sea. However, these were never very common animals, with only 3 genera ranging from the Paleocene to the early Oligocene. The Nigeropheids were a fairly common basal family within Alethinophidia, living in mostly estuarine and riverine environments across Africa, Europe, India and Asia during the Paleogene. Numerous genera have been recovered across this range, including the 1.5 metre semi-aquatic Krausophis from the Messel Shale, Tangyrakis from the late Paleocene of Morocco, and the 3 metre Kushophis from early Eocene Pakistan. More adapted for living inland than other marine snakes, and facing stiff competition from the much larger and bizarre Paleophidae. These animals experienced a decline after the Paleocene-Eocene thermal maximum. By the Holocene, a small number of species inhabit semi-aquatic and fossorial niches in Central Africa, Madagascar and Southeast Asia. Speaking of paleophids, these were, and still are, a very important lineage of marine snakes, possessing many adaptations to an aquatic, sea-going existence, including a degree of endothermy completely unprecedented in squamates outside of Mosasauria. Larger than the contemporary Nigerophids, some Paleogene forms reached gargantuan sizes of 10 metres and inhabited a transatlantic range. The genus Eupaleophis has been recovered from the Paleocene and Eocene deposits in North America, the UK, Italy, Algeria and Egypt. The most complete fossils of this family come from the late Eocene of Egypt and belong to a 60% complete specimen of the genus Apep giganteus, a massive 8-metre aquatic ambush predator. These snakes did not decline after the end of the Eocene, with their endothermic metabolisms and fast growth patterns enabling them to colonise waters further afield. A more ancient lineage of marine reptiles were also present, the Sauropterygians. The fusiform polycotylids persisted in the Paleogene, being somewhat analogous to reptilian penguins. Although once numerous, these animals appear to have declined somewhat during the Paleocene and into the Eocene. It seems that other marine predators may have edged them out, particularly the fast-swimming halosaurians, the plotosauroids, and, in the southern hemisphere at least, the anatophocoid monotremes and the polarornithoid diving birds. However, by the late Eocene, genera within this clade began to grow larger and increasingly raptorial. With the total extinction of the hypercarnivorous massive mosasaurs at the end of the Eocene, descendants of polycotylids moved into a niche of apex predator during the Oligocene. During this period, the clade Tiamatoidea emerges, producing larger and larger forms, culminating in the 25-metre long, 80-ton Thalassophonius during the late Miocene. However, these giant predators did not respond well to the oceanic cooling of the Pliocene, which heavily reduced the number and diversity of their prey. Current Holocene forms are now rare animals, inhabiting the Pacific Ocean as the single genus Morson diptes. At 8 metres long, this hunter of large fish and cephalopods is very modest when compared to its formidable deceased ancestors. The famous long-necked elasmosaurids were also present in the Paleogene, although with some notable exceptions. The iconic Cretaceous Elasmosaurus and Styxosaurus were gone before the KPG extinction event, leaving only the stem elasmosaurs and the Wedelonectons to swim on into the Paleogene. Of these, the Aristonectines and relatives were the most successful and widespread, with some reaching very large sizes. The stem forms radiated out as slender, superficially Elasmosaurus-like piscivores around the time of the Paleocene-Eocene thermal maximum, but declined significantly as the world's oceans began to cool later in the period. The Wedelonections were marginal creatures, possessing a near-global range in the Eocene but being low in number. The major exception to this rule was the land at the bottom of the world, Antarctica. This was the stronghold of the Wedelonections, with the group being rather diverse here, ranging from the huge cruising descendants of the Aristonectines to the much smaller speedy Morenosaurines. At the Eocene-Oligocene boundary, all Aristonectine relatives became extinct, while the less specialised basal forms survived into the Oligocene. After a brief period of recovery that saw Elasmosaurids journey back to southern Africa, South America and Australia, By the end of the Oligocene, new forms of competition drove these animals to a purely Australian distribution. This Pacific lineage adopted an unusual pinniped-like existence in the face of new threats, evolving a strong convergent resemblance of the polycotylids. In this mode of existence, the last bodylonectans would persist into the Holocene as highly derived, social, and rather intelligent predators, finally succumbing to extinction roughly 5,000 years before the arrival of Alter-Earth explorers and scientists. This is a shame, as these were undoubtedly one of the strangest and most spectacular marine reptiles that ever lived. There is far more that I have yet to cover on this subject, including the evolution of the anatophocoid monotremes during the Eocene, the spread of basal aquatic choristoderans in the Tethys, and the expansion of the flightless vergaviforms in the southern hemisphere. I will examine these in detail in a future episode, however. Thanks for watching, everyone. Next week I'll be covering the okapi, the rare African forest giraffe. See you again soon. Cheerio.